of all, thank you everybody for coming today. I'm excited to talk with you about basically what's happening with Gears. Actually, over the past year or so, the project has evolved quite a bit. And so today I'm going to be talking about what's changed and the direction that we're going as we move forward. And I think it's some pretty exciting stuff. But to start with, let me give a little bit of background about what is Gears. And at its core, Gears is a browser extension. The purpose of Gears is to provide new APIs to web browsers. And we do that by providing them as JavaScript APIs. Because when you're writing a web application, JavaScript is the native language that you use. The other thing that's interesting about Gears is that it's one of Google's open source projects. So this means that all of the source code you can download and see it. All the discussions about new features happen on a public mailing list. And the license for the source code is very open. So it's a new BSD license. And that means that you could take the source code and use it in a commercial application if you wanted to. We're very serious about making sure that people know that this is not just a Google project. We want this to be useful for everybody and for the web as a whole. And finally, Gears has an important goal to be ubiquitous. So that means that we want Gears to work across all different browsers and all different platforms. So today, Gears works on Linux and Mac and Windows. And it also works on desktop and also mobile devices. So we support Windows Mobile. And also, Gears works across different browsers. So we support Firefox and Internet Explorer. And this is really important for web developers because if an API doesn't work on all the browsers, that means that you can't really use it in your application because you want your application to work across as many machines as possible. The other interesting thing is that this is the one-year birthday for Google Gears. We launched about 1 year ago at the last Developer Day. And like any good birthday, this one comes with some nice surprises. So looking back at these points that I listed earlier, the fact that it's ubiquitous, I told you what browsers that we already support. We're also adding support now for new browsers. We're adding support for Firefox 3, and we're also adding support for Safari. Also, Opera has said that they are going to add Gears support to Opera 9.5 on the desktop and also on mobile. So we think this is good because it means that Gears will be available across even more new platforms. On the open source front, we're happy to talk about how today we're removing the name Google from the project. So instead of calling it Google Gears, we're only going to call it Gears. And this is a symbolic move. It's meant to show that we really do want this to be an open project that anybody can contribute to and anybody can benefit from. We don't want this to be just a Google thing. And finally, in terms of extending the browser, we're adding a lot of new APIs and new features that weren't available before. And this is going to be the focus of my talk today. And I think it's a very exciting area. So I think a lot of people may have a misconception that when they hear Gears, they think Gears is about offline applications. And for our first year, that was true. We wanted to make sure that as a first step, we allowed applications to work offline. But if you look at the modules that we exposed, we don't have a sync module, we don't have an offline module. We tried to provide basic building blocks, things that could be used in new and other ways that were not just offline. And in reality, offline was our vision for the first year, but all along we've had bigger hopes and bigger dreams for the project. And so as we go into our second year, I want to talk about what our vision is. Basically with Gears, we want to make it possible to create web applications that are just as powerful as desktop applications. And the way we want to do this is by exposing the capabilities of the local machine. So if you think about it, I have a laptop here, and it's very powerful. It has a multi-gigahertz CPU, it has gigabytes of RAM, it has lots of hard drive space, and it has interesting peripherals attached to it. But a static HTML page does not expose all those capabilities. Things like on-click handlers just aren't taking advantage of all that power that I have in front of me. And so that's what we want to do with Gears. We want to let you do things that you couldn't do before, and we want to do it by adding new APIs to the web browser. So as we provide these new modules, we have a few things that we try to keep in our mind. And the first one is that we want to fix real problems, real pain points that people have today when they're writing web applications. We don't want to try to come up with a grand framework that is just a collection of APIs that nobody would use. We want to solve real problems. And second, as I mentioned, we want to provide general purpose building blocks. We think that XML HTTP request is a good example of how you can't predict how people will use your APIs in the future. The best thing to do is to provide very general purpose and very generic APIs that people can use in interesting ways that maybe we didn't think of. And finally, we want to make sure that when we add these new APIs, we expose these features in a very safe way. And what that means is that web applications have a very big advantage over desktop applications because there's no penalty for trying them. If I send you a URL, you aren't afraid to click on it because you know that there's no risk of getting harmed if you click the URL. And also, desktop applications are very easy or web applications are very easy to use. So we want to make sure that as we add new APIs, these APIs continue to be safe. If you navigate away from the page, there should be no penalty for trying that URL. And the web applications should never be able to do anything bad to your machine. So a couple notes about the features that I'm going to describe today. The first one is that all of these things have been happening in the public. So that means that the source code is available now in our source code repository that's public. And also, all the discussions about these APIs have happened in the public as well on our public mailing list. I also want to point out that we are not announcing any new APIs today. What I'm showing you are working prototypes of things that we think may become APIs, but these are still in the early experimental stages. And with that, let's get into the details of some of the APIs that we're exploring. The first one is desktop shortcuts. And this is a feature that may seem somewhat small, but it's very important for the usability of web applications. And I'll describe to you what the problem is today. The problem is that when I start a web application, it's a lot more work than it should be. As an example, I have a set of demos that I'm using during this presentation today. And if I want to load the page for the demos, if it's not open, then I have to type in the full URL of the page. And even with tab completion, it takes some time. So since I'm going to be doing this a lot, what I'd like to do is have a shortcut that allows me to easily access these demos. And browsers today do have a way to do this. You can take the fave icon in the URL bar, and you can drag it onto your desktop. But the problem is that this doesn't look very good. You can see that it's a different icon than I expected. And also, sometimes you get the fave icon. But even when that happens, the icon happens to be very low resolution. The other problem is with the title. This says main index. But I don't want it to say main index. That just happens to be the title of this page that I used. So how should it work instead? Well, I should be able to do something in my web application where it asks me, would you like to create an icon on your desktop? And so I can say, yes, I'd like to create a desktop shortcut. And now I see exactly the icon that I want to put on the machine. It's not controlled by the browser. It's controlled by the web application. Also, you can notice that the title is exactly what I wanted it to say. This wasn't controlled by the browser. It was controlled by the web application. So now if I want to reopen this page, I just double-click on the icon, and Firefox will launch for me at that URL. So let's get rid of this one, since this is the one I'll use the rest of the day. So as I talk about these new APIs today, I also want to tell you a little bit about what is happening underneath the API. And so I'll start with the shortcuts. When I click that link, what's happening is it launches the browser that created the shortcut. So this lets me, if I wanted to, have one browser that I use for mail and a different browser that I use for my calendar. And by creating shortcuts in those applications, they'll launch the browsers that I want to use. Another thing is that we chose the icon sizes in our API to look good across all different platforms. Remember that Gears supports desktop and mobile, and it supports Mac and Linux and Windows. So you want your icons to look good everywhere. So by only providing 4 different icon sizes, you can make sure that your icons look good across all those platforms. And finally, one small note is that when you create a desktop shortcut, only one shortcut can have a given name. So if there's already a mail shortcut, you can't create a mail shortcut. But usually what happens is you put the name of your application, and that will be unique. I also want to show you an example of the APIs today, because I think that we've done a good job on Gears with making the APIs very easy to use and also very simple, but powerful at the same time. So in the case of create shortcut, we take 4 parameters. We take the name that we want to appear on the desktop. We take the URL that should be launched when you click the shortcut. We take the list of icon sizes that you want to show, and an optional description field. And you can see a sample here of the code itself. So if you've ever looked at the Gears APIs, every API starts with a call to factory.create, and you pass it the name of the module that you want to create. And then from there, we just call create shortcut on that module. In this case, the module is our desktop module. So you can see that I just passed those 4 parameters. I passed the application name, the URL, the list of icons, and a description. And that's all there is to it. It's very easy to use. Okay, so that was the first feature that I wanted to talk about. Let's move on to desktop notifications. And the problem today is that it's very hard for an application to notify you when something important happens. Let me give an example of that. So today, if an application wants to tell you an important message, it can do things like call alert. But alert has problems. If you look at this alert here, it's trying to tell me something important, but the formatting is very bad. I can only put a string message, and I can't change the highlighting or the color or the layout at all. And I can't put any pictures in here either. So that's not a very good experience. Even worse, if I happen to be visiting another page when the alert happens, then it's a very bad experience because it changed my page that I was visiting. So sometimes applications try different tricks. One of those tricks is to change the title of the window. And in this case, you see that there's some scrolling happening to try to tell me about an important message. But if I happen to be looking at a different tab, I may miss the message, or if the browser is minimized, it may be disappeared completely. So again, this is not a good experience for the user because the application cannot tell me about something important that's happening. So instead with Gears, how do we do it? Well, if the application wants to tell me something, if it uses Gears, now you see that I get a toast appearing outside the browser. And just to show you that it's outside, let me change the browser size. And so this looks very natural. It's a good way for a web application to tell me something important has happened. You can see that I have different formatting for different important messages, and I can also put an icon in that field. The other very interesting thing about this API is that if I close my browser, the notification still appears. So this is good because if I have a calendar application and it wants to tell me about an important meeting, it means I don't need to have my calendar application open all the time. I can close it and I will still get the important messages. So how is this working? Well, in Gears, what we've done here is we have a little executable that runs outside the browser, and it sits there waiting for messages to come. And when it receives a message, it shows them. So that's why it can work even if the browser is closed. Also, we know that some people want to use existing notification systems. So for example, on Mac, Growl is a very popular notification system. And so we don't want people to have to learn a new system. We want to send the messages to the one that you are comfortable with using. Again, the API for notifications is very simple. It's just 3 methods. You can create a notification. After you create it and set properties on it, you can add it to the system. And if you decide that you don't want to have the notification, you can remove it from the system. The properties that you can set are shown here in the bottom. You can set things like the icon, the title, the subtitle, the description, and an action. An action would be a link that appears inside the notification that if you click on it, it launches a URL. And also, you can choose to display the notification at a particular time instead of immediately. Here's a code sample that shows the notification being used. You can see that, as usual, I call factory.create, and then I just say create notification. And from there, I set the properties that I care about on the notification. And when I'm done, I call add. And that's all there is to it. It's very easy to use, very simple. Again, we want to make it so that you can solve the pain points of web applications, but in a very easy-to-use way. The next area I want to discuss is the file system. And you might be thinking, well, why do I need to access the file system? Or what's wrong with the file system in today's browsers? And I think there's a pain point that many of us feel if we use email programs and we want to do attachments. If you want to attach things to the email message, you have to select things one at a time. And similarly, if you want to use a file upload site, you need to select your photos individually as you're doing it. So I'll show you an example of this. Today, if I have multiple files that I want to select, what I have to do is first navigate to the directory where I'm going. And I would like to select all these files, but I can't. If I try, it says I can only select one at a time. So I select one, and then I select the second one, and as I put more in, I have to keep clicking each file individually. So even for a very small number of files, this is very painful. This is not a good experience. Here's how it should work, and here's how it does work with Gears. I say browse, and then I can select all the files at once. And when I open, they all appear here. It's very natural. It's exactly how you want the APIs to work. It's a limitation of browsers today that you can't do this. But with Gears, we want to remove that limitation of browsers. So a couple things about that actual implementation. You noticed that we saw the native operating system look and feel. This was not a custom UI just for Gears. This is the same UI that, as users, all of us are used to seeing day to day. So that means that it looks like a Windows UI on Windows. It looks like a Mac UI on Mac. Also, remember that we want this API to be safe. We don't want to add any security issues. So access to these files does not persist. Basically, you get a handle to the file's contents, but if you close the browser, you can't look at that contents again. And finally, the user has full control. So you noticed that I had to select the files manually. The web application could not say to open a particular file name. This was all under the control of the user. So this is very important for security reasons. Here's the API that we expose for file system access. It's just one simple call, load files. And we can pass options to that if we like. We can say what file types we want to accept. So if we only want to support images, we can say only support image types. Or similarly for movies or other types. And finally, we can say whether we'd like the UI to be multi-file or if we only want it to allow a single file. The object that gets returned is this file object described at the bottom. And the file object is very simple. It only has two properties. The first property is the file name, and we remove the path from the name so that for privacy reasons you can't get extra information. And the second thing is something called a blob, which I'll describe in a second. And that's a handle to the content. So you might be thinking, what is this blob? I've never heard of it before. And it's the fourth thing that we're describing today. Basically, if you've ever written code in JavaScript, there's no way to deal with binary data. JavaScript as a language does not have the notion of a byte. It's a very common concept in other languages, but JavaScript doesn't support it. But usually this is okay, because you don't want to manipulate bytes directly. What you want to do is higher level operations. You want to get a handle to an image and maybe put it into a database or maybe send it to a server. You don't want to change the actual bytes in the image usually. The very interesting thing about blob is that it can be used in almost all the APIs that we have today. So for example, with the database API, you could take a blob and you could store it into the database. With the HTTP request API, you could take a blob and you can send it to the server. With the worker pool API, you can take a blob and you can send it to a background thread to be operated on asynchronously. Here's what our interface looks like. So a blob only has two fields. It's very simple. You can look at the length, and you can take a blob and you can chop it into a smaller piece and get a new blob. But there's no way to actually manipulate the bytes directly. Basically, the blob is read-only. And the reason we do this is because if it wasn't read-only, there'd be some problems. Let's say that you take a blob and you pass it to an asynchronous function, like XML HTTP request. If that runs asynchronously, what happens if you could change the blob after you said to send it? If it changes in the middle of being sent, the behavior would be undefined. So instead, if an API wants to change a blob, it returns a new blob with the new contents. The thing that's very interesting about blob is that it adds a lot of new features that maybe not be obvious. So think about this. If I have a large file that I want to upload to a server, the problem today is that if the network gets interrupted at any point, I have to start over. And especially for things like videos or other large files, that's a very bad experience. Because if I've been sending 500 megabytes and then the connection fails, I have to start over. So let me give you an example. So this is a page similar to a site like YouTube. And if I want to upload a video today, what I do is I select it, and then I start uploading. And I don't get any progress information, so I don't know how far along it is. So that's not very good. And also, if my network connection goes away, even for just a second, and it comes back, there's an error and it doesn't continue. So now I need to start over. So it's not a very good experience if you're trying to do large uploads. Instead, here's how it works with Gears. I say I want to add my video to the list. And then once I start uploading, you can see that I'm going to get progress messages. So you see it's at 1% and 2% and so on. And even better, if my connection gets interrupted, it stops, but as soon as I reconnect, it's going to resume. So I don't have to start over. If I got to 99%, it just continues automatically. So a much better user experience for the user. And the very cool thing about this API is that we didn't have to add something just for resumable upload. Instead, we use the blob. We use the feature of the blob that lets you slice it into pieces, and we use the feature that lets you send a blob to the server using HTTP request. So here is the pseudocode for doing resumable upload, and it doesn't require a new API at all. You take the original blob, and we chop it into pieces. In this case, we chop them into 1 megabyte pieces, and we send each piece to the server. And if at some point one of the pieces gets interrupted, we just start over with that piece and send it again. And we continue where we left off. So in about 8 lines of code, we're able to do resumable uploads without any special APIs. This is one example of why I think the blob will be a very powerful way to add features to web applications, especially as we use it more and more. Finally, I want to talk about geolocation. And this is an exciting area, especially because if you want to do a search and you want to type in your location, it's a very bad experience. So let me show you an example. Let's say that I'm here in Beijing, and I would like to find a place to get some coffee. So today, all I can do is I can say, I'd like to search for coffee, and I enter my location. And because I'm not very familiar with the city, I just know the city name. And when I do a search, here's what comes back. These results are scattered far across the city, and the API doesn't have any knowledge of where I am. So if I'm around here, I have results that are sometimes 5 kilometers away. That's much too far. It's a very bad experience. Instead, here's how it should work. I should be able to say, I want to find coffee, and I want it to use my current location. Now for this demo, my laptop does not have GPS, so I've simulated GPS for this laptop. Here's what happens with the Gears API. You can see that because it knows my location, here's the conference center, and all of the results now are very, very close. Google search works exactly the same as it did before. The only difference is that now we added the latitude and longitude of the current location. And now the search results are much, much better. So with that very, very small change, we can get much better personalized location-based results that we couldn't get before. So how does this work under the covers? Well, first of all, we look at all the signals that we have available to us. So GPS is one example, but also we can look at the Wi-Fi ID if you have Wi-Fi. We can look at the cell ID if you have a cell phone tower. We can look at your IP address. And we take all those pieces of information and we send them to a server that your web application decides to send them to. And Google will have a free example server, but other companies may have geolocation servers as well. And after you send that data to the server responds by looking at all those signals and figuring out what your location is. Now, as I said, that service provider is completely customizable. So if you want to choose to use a Yahoo service provider or a Skyhook service provider or another service provider, that's totally up to you as the web application developer. Here's what the API looks like today. It's very simple. First of all, there's a way to get the last position. And this has zero delay at all. So immediately you find out where the machine was the last time one of the APIs was called. Second, you have a way that you can ask the machine to start a new request for a location. And this is where it takes all the signals and sends them to the server and gets the results back. And this takes a little bit of time. And finally, if you want to watch the position as the user moves around, maybe for a map application, you can say that you'd like to watch the position. And you can also remove that watch when you're done. You get a few pieces of information when you use these APIs. As I mentioned earlier, you get the latitude and longitude. You also get the altitude if it's available. And there's a way to know how accurate it is. You get both horizontal accuracy and vertical accuracy. And finally, you get a timestamp to know when the location was retrieved. Here's an example of the usage. As usual, it starts with a factory.create call. And after that, I just call get current position. And in this case, I use it to update a map. So I pass in a function that I want to be called whenever I use get current position. And that function gets called with the position value. And similarly, if I want to watch the position, the API looks almost exactly the same. I just call watch position with the same function. And it can use that to update my position over time. So these are just 5 examples of the kinds of things that we think Gears will be able to do over time. And as I said earlier, these are all working prototypes. If you download the source code from our source repository, you can build a version of Gears that has all these features that I've shown you. The question is, where do we go next? What's after this? And I think it's important to think back to the Gears vision that I talked about at the start. So remember, we have very powerful machines, or cell phones, or other devices, that have great web browsers nowadays. And as much as possible, we want to continue unlocking that power and making it so that web applications can be just as powerful as desktop applications can. We also want to make sure that when we add these new APIs, we expose them in a very safe way. The important thing about web apps is that you can navigate to a URL, and if you don't like it, you just close the browser, or you navigate somewhere else. There's no penalty for trying things. This is a key strength of web applications, and it's something that it's important for the Gears APIs to maintain. And finally, Gears is committed to being open source and open standards. We're doing all our discussions in the public. We're also working with standards bodies like HTML5 and W3C and WhatWG. And we're contributing these ideas and working with other browser vendors like Apple and Mozilla to create standards that will be available across all machines. We don't want Gears to be just a box of APIs that are disconnected from the browser. We want these APIs to be native and something that you can rely on working in any browser, anywhere you write a web application. And finally, I'd like to say that we encourage people to get involved. So if you'd like to use Gears in your web application and try some of these APIs, we have the URL here for using the project. And if you'd like to contribute to Gears, we also have a URL where you can get involved by downloading the source code and participating in email discussions and helping out in other ways. So with that, I want to thank you for your time, and I hope that you tried Gears. Thank you. I think we have some time for questions if people would like to ask them. And I think there is maybe a microphone.
大家有问题的话可以用中文提问，然后我帮他翻译。
Thank you. With the Google Gear, the web application looks much like the desktop application. But as we know, the JavaScript has a constraint on the access to the local resource. JavaScript only can access to the thing in the sandbox. So my question is, how did you overcome this problem in the Google Gear?
I'm sorry, how would you do what?
JavaScript has a constraint on the access to the local source.
It's limited to working on the local origin?
Sandbox.
Sandbox.
JavaScript can only access to the thing in the sandbox. But your application looks like much like a desktop application. So how did you access the local resource in the Google Gear?
Oh, okay. So the question was, how did we access the local resources?
Yeah.
I see. So with a browser extension, we can expose new APIs. And the extension has full control over accessing anything. It's our responsibility to do a good job of making sure that the access is safe. And we try very hard to do that. But at a technical level, there's no barriers to accessing anything. A browser extension can access anything on the system. So we use that feature. And then we expose the capabilities in a safe way. So we put the sandbox in place as much as possible. But a browser extension can do anything.
Yeah. Another question is about does the Google Gear only be used in the web application? And can we make use of Google Gear in the Firefox extension?
I see. So the question was, can we use Gears in a Firefox extension, not just in a web application? Yeah. I think there's a way to do it. There is somebody who has used Gears with Grease Monkey, I believe, which is an example of a Firefox extension. And I know somebody else was looking into it. But it's not our priority. Our number one priority is to support web applications. But I think it's possible.
Thank you.
Hello. Next. So can you explain a little more about the geolocation applications and how it works and the application is running?
Sure.
Okay. Thank you.
So the way that it works is service providers are able to drive around a city, and as they drive around the location, they see different Wi-Fi access points, or they see different cell phone towers. And so they remember, oh, when I was driving here, I saw Wi-Fi IDs 1, 2, and 3. And then when I was over here, I saw Wi-Fi towers 4, 5, and 6. And then when I was over here, I saw 7, 8, 9. And so then if you say that you're near Wi-Fi tower 7 and 8, the server knows, you must be around this location.
So you need to cooperate with the local service, the Wi-Fi network service providers?
Not necessarily, because companies can do this by just driving around the city with a Wi-Fi antenna and a cell tower antenna.
But you have to know the Wi-Fi access point ID, the location?
You can find all the Wi-Fi IDs by just driving past them and just seeing them.
Okay.
Yeah.
Okay. Thank you.
Yeah.
I have a question on the security issue, and if the client get the data, the users make some modification on the data on the client side, and how can you ensure that the data hasn't been modified when it is synchronized to the server?
Do you mean for file system access?
Yeah.
Yeah, that's a good question. So what we do for file system access is we make sure that the file modification time did not change. If the file modification time did change, then it means that the call to read the blob can fail because it would break the promise that it's read-only and non-changing. So that's the way we do it, is we remember, here's the file handle, and also here's the last time it was modified. And if it was modified outside the web application, then the read call can fail. Maybe somewhere over here?
I have a question. That is, can amateur developers attend the development of the Gears?
Yeah, the question was, can outside developers help with the development of Gears? And absolutely, that's what we want. We want Gears.
Does Google supply any plans or
any plans?
Any plans, just like a Google Code? Or
no, there's no restriction. Anybody here could sign up for the project and start sending emails to the other people on the team. And it's true that a lot of the team is Google employees, but it doesn't have to be. The team could be some Google employees and some Apple employees and people from schools. We want it to be based on the ideas themselves. And so if somebody has good ideas and wants to contribute good code, that's great. That's good for the project.
Okay, thanks.
Maybe in the corner?
Thank you, Chris. Nice talk. My question has to do with Gears on Mac WebKit. So I know there's a brief time Gears support the Safari, which is WebKit. But then right now there's no clear instruction how to do that right now. So when you have plan, what's the priority gonna support that? Thank you.
Yeah, so the question is about Safari support for Gears. And honestly, what happened was when we came out with Gears 1 year ago, we had a prototype for Safari, but it was done by one person in his spare time. So it wasn't something that we could support because he left the project. So we realized that Safari is very important. And right now, we're working on a version that will be supported going forward as soon as it comes out. And we hope that will be available in the next 2 months, maybe 3 months. Maybe here and then back there.
Are all the features you mentioned only suitable for Firefox? Are they also supporting for the other browsers?
Yeah, everything I showed here today works across different browsers. So I happen to use Firefox, but it would work in Internet Explorer also.
If what you mentioned is geolocation, and what if I'm using the PC and the IP address to notify what is my current location? So what if I'm using a proxy? Right. The server maybe in Paris or in Russia?
Yeah.
How do you deal with that?
You won't get good geolocation.
So is it working correct?
Oh, I'm sorry?
Is it still working correctly?
Well, I mean, it will know the location of the proxy server because there's no other way to know anything else. But if your laptop has Wi-Fi turned on and you can see Wi-Fi towers, then we can use that information to figure out position. And also, I didn't show it in the demo, but again, security is important. So we don't want to let a web application spy on the user. The user will have to say, I want to allow this web application to look at my position. That's the only way it can access it.
Is it possible that, for example, IE, when concerning with some security issues, and will prevent the extended features on the browser?
Can you prevent which?
Prevent a blockage when concerning some security issues.
Can you block Gears?
Yeah.
You could not install Gears. I mean, also, the APIs, so here's how we approach security. Either we make sure the API is completely secure and can't do anything bad. And in that case, there's no UI, no prompt. And one example would be the database API. it's all sandboxed, so you can't read anywhere on the system. So that's a safe API. And then there's APIs that it's important for the user to give their permission. And things like location would be one example.
So will all the features will work properly and effectively on all kinds of browsers?
That's right.
Oh,
Yeah.
thank you.
I think there was a question in the back. And then we'll come back to this side again. Oh.
我就用中文问吧。我对这个 Google Gears 离线功能比较感兴趣。我感觉加入这个离线功能以后呢，Web 应用它能真正的跟这个本地应用相匹敌。那么我想问一下，Google Gears 提供的 API 怎么保证？就是说我开发的这个应用，如果我用了 Google Gears API 来实现离线功能，那么它怎么来保证我存取文件这安全性呢？我可不可以就说我随便的存取，会不会把别的应用程序的这些文件给冲掉呀，或者其他的安全性问题怎么保证？谢谢。
So the way that the file system API works is the only thing it can do is ask to show a prompt. And the prompt has no information filled in. So if the user closes the prompt, the application does not get access to any files. And by default, the prompt does not have any file name in it. It's completely empty. So it's a very limited API if the user doesn't do anything. If the user does not want to expose a file, the web application cannot see the file. Any other questions? Looks like one in the back.
Hi, Chris, thank you. I have two questions. The first question is about we know Google have Android platform that Google have planned to deploy to Android platform. This is the first question.
We are. Oh, okay.
Okay. Second question is about Google offline function. So we know if we want to supply the offline function, and background we have a local server. How about the local server? I think the local server it functions as a HTTP server. So I want to know the roadmap about the local server. Thank you.
Okay. So the first question was about Android. Will Gears be on Android? And we haven't made any promises, but if you look in the source tree that's public, we are doing some check-ins about Android. So we want to support Android. We think it's an important platform. It has a very good web browser. And so we don't have a timeline, but work is happening on Android today. Yeah. The second part was about local server and how does it work. Is that correct? So basically what happens is Gears sits inside the browser, and it watches all the network requests that come out and go in. And if it sees a URL that has been captured by the web application, it says, oh, the web application told me that when I see this URL, I should serve this content. So it intercepts that URL and sends back the content directly, and it doesn't go to the server. That's basically how local server works. Okay, so I think that's about it. If people have more questions, there's going to be a speaker poster session near the registration at 5:30 p.m. So feel free to come by and ask other questions. And again, thank you all for coming. Appreciate it.